Determine whether the series, so we're using index k, so k equals 1 up to infinity of 2 over k cubed minus 3 over 2 to the k. Okay, similar looking expressions. Determine whether this converges or diverges. Okay. So, converging, diverging, we want to try and maybe use a test or some other knowledge and primarily focus on the sequence that we see. So what sequence do we see? 2 over k to the 3 minus 3 over 2 to the k. Now, they do, the two expressions there that we're taking the difference of look somewhat similar, but you might notice the different placements with the k's here. This part here kind of looks like a p series, or a p sequence, but we're adding things up. So I might say, okay, it looks like p series. Whereas this bit here with the to the power of the index, this is looking a little more geometric. So we have two separate things. But one of the things we know is if we were able to split them up, and just look at this sum, and then just look at this sum, if they both converge, then that would mean the whole thing, the difference of them, converges, right? That's theory that we have, that we know. So if we look at them individually, what have we got? Well, we know, without the 2 on top, we know this is a p series with p equals 3, so we know it converges. And we also know if you have a series that converges, you can multiply it by a constant and it will still converge. Okay? So, adding up the first sequence converges. Great, we've got that. We understand that. What about the second one? Just looking at the second sequence. Well, as we said, it really looks geometric. Now, if you think it's geometric, you should be able to tell me the first term and the r. That's really what you need, especially if you wanted to evaluate. But this question is not asking us for evaluate, but just while we're making the comment. So the first term, you plug in k equals 1. The first term will be 3 over 2 to the 1. So 3 over 2. This is what we typically call a, the first term in our geometric sequence. Okay, what's the common ratio? Now, if you do a lot of these, you can pretty quickly tell, like I can, the common ratio is 1/2. Okay, because we're always dividing by 2 each time. As k goes up, we're just dividing by more and more 2's. But if you're like, I'm not ready to eyeball it yet, that's okay. What you do is you take the first term, so with a k equals 1 in here, and you take the second term and you do second term divided by the first term. It's always next term divided by previous term. Okay, always, always, always. And okay, 3 over 4 divided by 3 over 2, and you'll get 3 over 4 times 2 over 3. You'll get 1/2 pretty quickly. So yeah, so with a common ratio of 1/2, whose absolute value is less than 1, we know this converges. And since the difference of convergent sequences added up is still convergent, we conclude that this one converges. Okay? So if we wanted to write it up nice and neat and explain it to people, we would just very carefully say, hey, this one converges. Why? Because it's a p series with, well, it's a multiple of a p series with p equals 3. And then we would say, well, this is geometric. How do I know it's geometric? Here's the a and the r, so you're convinced. And since the r in absolute value is less than 1, then it converges. And then I would say difference of convergent series is also convergent. And that's it. That would be the last little bit of my explanation. But the answer here, which is what we wanted, was this converges.